All right, we are back with day 7 of ACT Prep Unit 2, Pre-Algebra 2 topics. We're going to be talking about elementary counting techniques. All right, elementary counting techniques. There are some elementary techniques that can help you count very efficiently. This section reviews 3 of these techniques: products, permutations, and combinations. Factorials are often used to find the number of permutations or combinations. So on a calculator, to get there, what you do is you hit your math key. You're going to arrow over to PRB, probability. There's your factorial, and then you want these two. This is a permutation, NPR, and this is a combination, NCR. Okay? So you need to know where those keys are. All right, products, you may just need to multiply. Look at the example below. It says you're buying frozen yogurt cone. The yogurt store has 3 different types of cones, 6 different flavors, and 8 kinds of toppings. All you have to do to find out how many types of yogurt cones you can buy is multiply all your choices together. You have 3 choices for a cone, you have 6 choices for a flavor, you have 8 choices for your toppings. Multiply those together, you get 144. Okay? A permutation is the arrangement of a certain number of items in a specific order. And when you do permutations, in other words, you're always going to either use permutation or combination. When order matters, then you have to use permutation. When the order doesn't matter, you use combination. So for example, 3 students, Alex, Bonnie, and Charles, line up single file. How many different ways can they line up? You can try and make a list, but this gets very, very cumbersome. You could put Alex, then Bonnie, then Charles, or you could put Alex, then Charles, then Bonnie. You could start with Bonnie and Alex and Charles, or Bonnie and Charles, and you could go through all those possibilities. But the order matters, because if you put Alex first, then Alex is out. You don't have a choice. Alex isn't a choice for position 2 or position 3. So the order matters. And one way you can do it when you're doing order is you can just do 3 factorial. Okay, you got 3 students, you're trying to line them up. I don't care for the factorial. To me, what this says to me is you have 3 students, okay, and you're trying to line them up. All right, so you're taking 3 students. You have three students. You have 3 places in line, and you're taking 3 at a time to put in those 3 positions. You're picking those 3 kids and you're putting them in a certain order in those 3 positions. So you have 3 spots and you're taking 3 at a time. That's a permutation. And when order matters, okay, you can type 3 factorial and get 6, but I don't really care for the factorial. The permutation makes more sense to me. Oh, I thought I put that in there. I didn't. Sorry, if you typed in, you would type on your calculator, you would type the 3, then you would do math, prob, and pick this, and it will put this on your screen, and then you have to type your R, and you put 3 here, and you will get the same answer. I thought I put that in there. Okay? So it says use 6 factorial to find the number of different permutations of 6 items. Again, you could do 6 times 5 times 4 times 3 times 2 times 1. All right, you could also do 6p6, and it will give you the same answer. Okay? And then you have to memorize this special rule. 0 factorial is 1. It's not 0, it's actually 1. Okay, so if I have 9 students, we're going to line up single file for movie tickets. And how many different ways can students line up? Again, you could do 9 factorial, or you have 9 spots to fill, and you're taking them 9 at a time, which would be 9 NPR 9, and that would give you the 362,880. Or you again can do the factorial. Okay? All right, my permutation formula. What the calculator's doing when you type in that NPR, it's doing this. Okay? So it says you can always use this formula to find the number of permutations or ways of arranging n items in R positions. Okay? So, I'll explain that in a second. Okay, so for 1, it says 4 students in a club are interested in 2 positions. So you have 4 students, and you have to put them in 2 different positions. but specific positions. In other words, if you make one kid the president, he can't be vice president. So again, order matters. So when I do this one, okay, I have 4, and I'm taking them 2 at a time. I have 4 kids, and I'm filling 2 positions at a time. So order matters. This formula, let me explain it this way, and then I will show you on the calculator. Sorry, I was looking at my notes. Okay, so n equals 4 and r equals 2 because we have 4 students and we're filling them 2 at a time. So in this formula, you'd put 4 factorial over 2 factorial. Well, you type it in a calculator, but what 4 factorial means is 4 times 3 times 2 times 1. What 2 factorial means is 2 times 1. Those cancel, and you get 12. Me, I like the calculator, okay? When order matters, you're picking permutation. So math, prob, 2, but you got to type in this first. So you type the 4, then you hit math, prob, 2. This shows up on your screen. Note you type this first, then hit this key sequence, and then you type your R, your 2, and we get the same answer. So there's 12 ways. 2 says there are 5 cars and 3 parking spaces. In how many different ways can the cars be parked in the spaces? Again, you have 5 cars, and you're filling, so you're taking 3 at a time. So you got 5, taking 3 at a time. And again, order matters because if one car goes into the first spot, that car can't also be in the second spot. So order matters. So we can do, they did it the long way, the factorial way. Again, calculator, you type in 5 NPR 3 and you get 60. Okay? Combinations. The combination is an arrangement of certain number of items in which the order does not matter. So for combinations, order does not matter. For example, there are just 2 parking spaces but 4 cars, red, blue, yellow, and green. In how many different ways can 2 cars be parked? Order doesn't matter. So we're taking 4 things, 2 at a time. But order doesn't matter, so instead of using permutation, we're going to use combination. I mean, they made a list. You could do red, blue, then red, yellow, red and green, blue and yellow. And again, blue and red, the order doesn't matter because if red and blue, blue and red is another option, but it's the same thing because we said order doesn't matter. I don't care where the red one is, where the blue one is. It's not like red has to be in the president's, you know what I mean? It's not a specific. Order doesn't matter. So we do combination, okay? 4 taken 2 at a time is 6. Alright, so you can always, again, there's a formula for combinations, just like there is for permutations, but again, with the calculator, you go to math, prob, and there's your combination key. So it says there are just 2 we just did this. Why? Did it back up, or what did it do? Okay, so you try this one, hit pause, come back when you're ready. And you should get 20. There are 3 job openings for level 1 computer technicians and 6 applicants. How many different ways could these 6 applicants be chosen to fill the 3 job openings? The order doesn't matter because they're all going to be level 1 computer technicians. It's not like you're choosing one for president, one for vice president. They're all going for the same position. So order doesn't matter. And you have 6 taken 3 at a time. So we do our combination, and we get 20. Okay. On 1, it says, how many different ways are there to place 5 books on 5 different shelves if you can place only 1 book on each shelf? So that means that order matters. Okay? Order matters, which tells me I'm doing a permutation, not a combination. And we have 5 taken 5 at a time. So I can do the factorial, or I can do the 5 NPR 5, and you get 120. Number 2, if Andy has 7 shirts, 6 pants, and 8 ties, how many different outfits can he make with the pants, shirt, and ties? This is like the yogurt cone. You have 7 shirts, so 7 choices for shirts, times 6 choices for pants, times 8 choices for ties, and you get 336 possibilities. Number 3, there are 4 coach seats left on an airplane and 7 people waiting for those seats. How many different ways can you choose people to fill the 4 seats? Okay, well, does order matter, or does order not matter? It doesn't matter because they're all in the same coach seats. Okay, so you have 7 taken 4 at a time, and order does not matter, so we do, oops, out of order there. We do combination, which gives me 35 possibilities. Okay, number 4, there are 4 people running for 4 different positions: president, vice president, secretary, and treasurer, which means order matters, because now you're picking certain people for certain positions. How many different ways are there to place 4 people into these 4 different positions? You have 4 positions, and you're taking 4 at a time. You could do the factorial here. I prefer the NPR. Okay, so there'd be 24 possibilities. Alright. 5, for breakfast, Jane has cereal, orange juice, an apple, and a piece of toast. Jane keeps 4 different types of cereal, 2 different kinds of orange juice, and 3 types of apples, and 2 types of breads. How many different breakfast choices does she have? Well, again, this is just multiplication. She has 4 choices for her cereal, times 2 choices for her juice, times 3 choices for her apples, times 2 choices for her bread, which comes out to 48. Okay, 6, there are 6 puppies born, but the mother always feeds only 4 puppies at a time. How many different groups of puppies can she feed at one time? The order doesn't matter. Any 4 can go eat. Okay, so you have 6, but you can only take 4 at a time. And the order doesn't matter. So you do the combination, not the permutation, and you get 15. Okay? And then number 7, there are 5 windows in a room, and Rich bought 5 different curtains to go on the windows. How many different ways can Rich place the curtains on the windows? Here the order matters, because once you put curtains on one window, you can't put them on a different window. Okay? So you have 5, and you're taking 5 at a time. And order does matter. You could do the factorial, or you could do the permutation. You get 120 different ways. Okay, number 8. It says Steve knows 5 notes on the guitar and plays 4 notes in a row. Not at once. He doesn't play them all at once, but he plays 4 notes in a row. Well, how many different ways will Steve be able to arrange his notes? Well, you have 5, 3, 1, 2, 3. He's going to play 4 notes in a row. He has 5 choices for his first note, 5 choices for his second note, 5 choices for his third note, and 5 choices for his fourth note, which gives him 625 possible combinations. Okay. Number 9. It says there are 9 different things to drink in Lisa's house, but Lisa only has 3 glasses. How many different ways are there to put the 3 different drinks in the glasses? You can put only one type of drink into each glass. That means order matters. So I'm doing permutation. You have 9 taking 3 at a time. So I type that in, and I get 504. Okay, 10. A 7-digit phone number uses all the digits from 3 to 9. How many different possible phone numbers are there? So you have 7, you got to pick 7 digits. 1, 2, 3, 4, 5, 6, 7. Well, on your first choice, your digits from 3 to 9. So you can choose 3, 4, 5, 6, 7, 8, or 9. So you have 1, 2, 3, 4, 5, 6, 7 possibilities. So to pick your first number, you have 7 choices. Now, I'm going to complain a little bit about the wording on this problem. we have to make an assumption here that they didn't say one way or another. They don't specify whether you can use a digit more than once. If they specified that you could use a digit more than once, then it would just be 7 times 7 times 7 all the way, because if you can use it again, then it's back in, and you still have 7 choices for your second digit, 7 choices for your third digit, and so on. But because I looked up the answer in the book that I got this problem from, my answer didn't match, so they have the assumption that you don't. You can only use each digit once. That's the only way to come up with the answer they got. So I want to write to this company and tell them this is really not a fair question, because you have to assume one way or the other, and they're not giving us any indication of whether you can or cannot use a digit more than once. But anyway, with the assumption that you can only use each digit one time, you have 7 choices for your first digit. Then you only have 6 digits to choose from for your second. Then you only have 5 choices for your third, 4 for your fourth, 3 for your fifth, 2 for your sixth, and 1 choice for your seventh. So if I multiply all those together, I get 5,040. Okay? Alright, you try this one, hit pause, come back when you're ready. And hopefully you got 28. It says 8 students try out for 2 openings on the debate team. And how many different ways can these 2 openings be filled? So you have 8, and you're taking 2 at a time. But there's 2 openings on the debate team. It's the same team. It's not like you're trying out for the president of the debate team and then the vice president of the debate team. Okay, so order does not matter, which means we're going to do a combination instead of a permutation. Okay, go, try this one, hit pause, come back when you're ready. And hopefully you got 24. It says a store manager has 4 different gifts to give to the first 4 people who enter the store. In how many different ways can he distribute the gifts? Order matters here, because when the first person comes in and he gives them one gift, that gift is no longer available for the others to choose from. So order matters. So we're going to do a permutation, and you have 4 taken 4 at a time, which is 24. Alright, try this one, hit pause, come back when you're ready. And hopefully you got E. It says a license plate has 3 letters, followed by 3 digits. How many different license plates can be produced? So you have to put a letter here, a letter here, a letter here, a number here, a number here, and a number here for your license plate. Okay? Again, this one is assuming that you can use them more than once. Again, even though it doesn't say, but the only way to get this answer is if you assume that you can use these more than once. So you have 26 choices, because there's 26 letters in the alphabet. You have 26 choices for your first letter, 26 choices for your second, 26 for your third. There are 10 digits in our number system, so you have 10 choices for the first number, 10 choices for the second, and 10 choices for the third. So I multiply all those together, and I get the 17,576,000. A lot of possibilities, a lot of license plates. Okay, try this one, hit pause, come back when you're ready. Hopefully you got 720. It says a newspaper editor needs 5 stories for the front page of the next issue. There are 6 reporters available to write the stories. How many ways can they be assigned if each story is written by only 1 reporter, which tells you that order matters? So we're going to do a permutation, and we have 6 reporters, and we're taking 5 at a time. Okay, so we do a permutation, and that gives me the 720. Alright, try this one. Hit pause. Come back when you're ready. This one is like the license plate one. It says how many 3-digit area codes can be created if the first digit cannot be 0. Well, we have 10 digits to choose from. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. But if the first one cannot be 0, then there's only 9 choices for your first number. But 0 can be the next two, so you have 10 choices again on the second and 10 choices on the third. Multiply those together and you get 900. And that does it for day 7. So I will see you next time for day 8.